Okay, welcome back, Trinity Classical Academy. Video number 2. I got interrupted with other urgent work-related things, but picking it up. In between the previous recording and this one, I was thinking about the maritime navigation example that I had given, and I realized that I think I was wrong, and then so I looked it up, and indeed I was wrong. How it works is if supposing you're a boat and you're located, anywhere in the ocean, and you have, you're trying to give details about where a possible bogey is, or different topic, targets, or you're trying to set a course. So you might say, hey, we're going to go bearing 10 degrees, which would be like somewhere up here. We're going this direction. So 0 degrees, a bearing of 0 or a bearing of 360 would be straight due north. A bearing of 90 would be straight due east. A bearing of 180 would be straight due south, and 270 would be straight due west. And then of course you have perfectly northeast, northwest, southeast, southwest, etc. And so as you're a sonar technician or a navigator, you would give your heading, you would give bearings, you would speak in terms of degrees, using 360 degrees as the reference point. Pretty cool stuff. The other way that you could look at this is, I think the Army, 0 degrees would be straight ahead of you, 180 degrees would be directly behind you. And so it doesn't matter where north is, it just matters, like it would be like if someone said, oh, 10 o'clock, I mean on a clock, it would be that direction, where 12 o'clock is wherever you're facing presently. But practical applications. Looking at page 25, 25 would discuss vertical angles. Notice how it's highlighted in your book. Vertical angles. That is a vocab word. Vertical angles are angles formed, they're the non-adjacent angles that are formed from straight lines. For example, let's angle it like this. There we go. So these are straight lines, and they're straight lines because they have little arrow hats on them. The angles that are across from each other, the non-adjacent angles, as it were, will always have the exact same angle measure. Always. Two straight lines intersect, their angle measures will be the vertical angles. Vertical angles will be the angles that have the same measure. Any two angles that have the same exact angle measure are called congruent angles. Congruent angles have the same angle measure. Therefore, vertical angles are always congruent. See how that works? So no matter what, if this is x degrees, then this will also be x degrees. And if this is y degrees, this angle will also measure y degrees. They are vertical angles. They are also congruent angles. Notice they have to be the intersection of two straight lines, not merely angles that are joined with a common vertex. So it's not enough that they have a common vertex. They have to be straight lines. Notice too, this will always be true, the adjacent angles, so the angles that are not vertical, will always form 180 degrees. So here's 180 degrees, here's 180 degrees, here's 180 degrees, and here's 180 degrees. No matter how we slice it, x plus y is going to be 180 degrees. The measures of x degrees plus y degrees will always add up to 180. 4 different ways. Pretty nifty, you guys, right? If you turn the page We're going to back this up just a bit. I'm just going to leave these angles drawn because they're already drawn. Makes sense. Also, in case you hear some like loud booms or stomping or crying or screaming, it's because now I'm not alone. I have, you know, my family with me while they're upstairs. I'm downstairs, and I'm next to the pipe, pretty close to the pipe of where the toilet flushes. So you might hear the whooshing sound, and that would mean that someone flushed the toilet, because you needed to know that. I feel like it'll be a really jarringly loud noise, so I just wanted to give you a heads up. That's all that is. So here in the example of the book, we have 2x degrees, and over here we have 60. And they give us that line AB and line CD are straight lines. Find the value of x. Well, we know that these are what? Go ahead, shout it out. These two angles, angle AOC and angle DOB, I haven't marked the points, but you see them in your book. They are vertical angles, which means they are also congruent. That means that they have the same angle measure. Therefore, 60 equals 2x, which means x equals 30 degrees. Easy peasy. Let's pause and do guided practice number 5. Okay, so you've paused. We're looking at guided practice number 5. They say that there's the angle at the top that measures 120 degrees, and there's the angle at the bottom that measures 3 times y degrees. And it asks you to find the value of y, given that those are straight lines. Sweet. So in case you've solved it, you can move on. The answer should be y equals 40. Here's how we get there. We set 3y. We know that they're equal because they are adjacent and therefore congruent. 3y equals 120. We divide both sides by 3, so y equals 40 degrees. Capiche? Very good. Example 12 applies the reasoning to find the measure of angles formed by intersecting lines. I'll tell you what, we don't need that anymore. Plus, we are on page 27 now. So page 27 says in the diagram there are angles 1, 2, 3, and 4. Find the value of each variable if the measure of angle 1 equals 76. Oops, I want that to stay there. All right. Zoop, zoop. All right, so they give us these angles. Tell you what, we'll use skinny pen. Skinny pen. So this one is 76 degrees. And they're like, well, how can we, just with this amount of information, how can we determine what these measures are, what the other measures are? Well, they told us that these are straight lines and that the measure of one angle is 76. Therefore, we should be able to figure out, this is angle 1, angle 2, angle 3, and angle 4. So if the measure of angle 1 is 76 degrees, then the measure of angle 3 also must equal 76 degrees. What else do we know about the properties of these angles that will help us out? Well, if you remember my rainbow pen, it's going to measure 180 degrees that way. So the missing measure, if this right here is 76 out of my 180, then that means I'm missing over here 104. Because I know I need to go from here all the way around to there. If I go here, I'm 76 degrees of the way there. What's the rest of my journey going to look like? I have another 104 degrees to travel. Sometimes if I phrase things differently, maybe that'll help things to set in differently. So we know that this angle has to be 140. Furthermore, we know that this angle has to be 104, because it's congruent, because it's vertical, not adjacent. So those are the measures of the missing angles. Now that we have that, I tell you what, I don't want to do guided practice number 6. I actually want to kind of do number 33 in the homework. We'll do that one together. The math journal. Oops. All right, math journal time. Page 33, or excuse me, page 31, number 33. We're going to do this one together. It says there's a diagram showing a pattern on a carpet. It says are angle 4 and angle 6 vertical angles? Explain why or why not. Everybody take a minute to think about this. I want you to be ready with an answer, and I want you to pause the video. All right, so hopefully you did that. So measure angle 4 and angle 6. They sure do look like they could be congruent, right? Looking at that pattern, we have this and we have this. And this is number 4 and this is number 6, and are they vertical angles? The answer is no. We cannot, they are definitely not vertical angles because they're not formed by the same two intersecting lines. They have to be formed by the same intersecting lines. Now it's very possible, and in fact likely, that they are congruent. They might have the same angle measure, but we cannot assume that unless they tell us information to that effect. All right, look at B. Suppose the measure of angle 4 equals the measure of angle 6. Cool, okay. So let me fill in the rest of these numbers. So supposing that they are congruent. So they say, let's suppose that 4 and 6 are congruent. Therefore, are angle 4 and angle 5 supplementary? Explain your answer. Once again, let's pause as you consider this problem. All right, so I hope you've reasoned through it, and I hope you have an answer and are ready to defend it and be able to explain whether or not angle 4 and angle 5 are supplementary angles. So let's take a look. So what we got here is we have, they gave us that these two are equal. That this one and this one are equal. I think we're supposed to also assume, they don't tell us this, but I think we're supposed to also assume that these are straight lines. So if that changes your answer, then we're looking at 4 straight lines that form 2 intersections. Okay? So hopefully, if that completely throws you off, then whatever. So given that these are straight lines, these will meet, this means that also angle 2 and angle 8 are equal. Let me grab a different color. Let's suppose this one, what color is that? Green. We'll use green. So those are equal, which also means that these 4 angles are all congruent to each other. So we have all of these congruent angles and all of those congruent angles in the blue and the green. We also know, marvelous rainbow pen, that we have, since this is a straight line right here, then this angle right here has to be 180. Likewise over here. So yes, the measure of angle 4 and the measure of angle 5 must add up to 180 degrees. By definition, since the measures add up to 180 degrees, then yes, they are supplementary angles. They do not have to share a same line. Any 2 angles whose measures add up to 180 degrees are supplements to each other. They are supplementary angles. Fun times, you guys? I thought so too. All right, so that's that's it for lesson 6.2. I do want to move into chapter 6 to lesson 6.3 as well. So we're going to do that because I said I wanted to. Zip. Whoop. Groovy. Okay, so here we go. We should be on page 32. So you do have some homework from 6.2. What am I saying? It's all homework. But we're also going to learn a little bit of the next lesson just to get started on it. And I really feel like it just flows right into the next one. So alternate interior and alternate exterior and corresponding angles. Look on the top of the page. You will see some vocab words galore. Like I said, chapter 6, all about the vocab. There's transversal, there's alternate interior angles, alternate exterior angles, and corresponding angles. So, looking at the blue words, identify the types of angles formed by parallel lines and a transversal. These are important relationships between angles. Don't do that. Do this. Be here. So, the symbol, that symbol in the book, it says the symbol parallel is used to denote parallel lines. In the diagram, line AB is parallel to line CD. So you can write line AB is parallel to line CD as shown there. Do I need to write that? I should. I feel like I probably should. So it looks like this. Line AB is parallel to line CD. Sounds like they're playing tag upstairs. All right, so they take two lines, for the sake of simplicity, I'm going to keep my ruler where it is, and they intersect it with a transversal. What? All right. So a transversal is a line that cuts across two or more usually parallel lines. Usually that's the point of the transversal, is that they're parallel. Spend some time looking at this. How many angles do you see? Simply speaking, we see 8 angles. But you have to remember too that each line itself is a straight angle of 180 degrees. And it also measures 180 degrees on either side of that line. So that means there's a lot of potential ways to measure out 180 degrees, which can really help us if we're trying to find missing values. So in the diagram below, PQ intersects AB and CD. PQ is the one that marches to the beat of its own drum. It's the one kind of going up and down diagonally style on your screen right now. So many angles are formed. Some of the angle pairs have different names. Let me slide over here so we can take a look a little bit more better. Oh, you've gone and done it. Forget it. All right. We got 1, 2, 3. Oops. Undo. No, come on now. 3, 4, 5, 6, 7, 8. Did I sound like a cheerleader there? I think so. 1, 2, 3, 4, 5, 6, 7, 8. So those are the angles that they've decided to name. Notice from the previous thing we just learned, we have here some vertical angles. 2 and 4 are vertical to each other. 1 and 3 are vertical to each other. 5 and 8 are vertical, and so are 5 and 7. Or excuse me, 6 and 8 and 5 and 7 are pairs of vertical angles. So that means they are congruent. However, we're going to not worry about that right at the moment. We're interested in the alternate interior and the alternate exterior angles. Looking in your book, the interior angles are between the parallel lines. Does that make sense? They're inside this little boxy thing that we've made. These are the interior angles in that color. Blue. Let's highlight with this color. What is that? Bright orange? Gross. Neon green? Come on now. Green. Green will be the exterior, why not? These are the exterior angles. You see, that's like a box. There's like a box, and there's an inside and there's an outside. So we can see that those names kind of make sense. But what about alternate angles? So 1, 2, 8, and 7 are exterior. 3, 4, 5, and 6 are interior angles. The alternates are the ones formed on the opposite side of the transversal. So the alternate interior angles are 4 and 3 and 5 and 6. Beg pardon, I did that wrong. 3 and 5 and 4 and 6. They're all the alternating ones. They're each on, they are going to be congruent. They are congruent. They're alternate interior angles. The alternate exterior angles would be 1 and 7, and different color, and we'll do the orange. 2 and 8. Those are alternate exterior angles. They are congruent to each other. Let that soak in a bit. There's another term here called corresponding angles. So the corresponding angles, they will lie on the transversal. They will share the transversal in common, but are formed by the opposite parallel. I feel like I need to renumber these again, or recolor these again. So the corresponding angles, 1 corresponds to 5. 2 corresponds to 6. Let's go down here, I guess. Guys, these highlighter colors are really throwing me. Gray? Really? Who ever heard of a black highlighter? Pink. Sounds good. 7 and 3, well, I depend on shapes. 7 and 3 are corresponding angles. And last 4 and 8, denoted by having no highlighter at all. So 2, 6, 1, 5, 3 and 7, 4 and 8. They all are corresponding angles to each other. So we see that with these 8 angles, there are a lot of different pairs that can be formed up. We've got vertical angles, we've got alternate interior angles, alternate exterior angles, we've got corresponding angles, we've got adjacent angles. The adjacent angles, I don't even think we talked about those yet. The adjacent angles are kind of easy because they're formed, they are 2 and 3 are adjacent to each other because they share this vertex right here, but they form a 180 degree, right? Same thing with 1 and 4. They're supplements. 5 and 8 are supplements. 6 and 7 are supplements to each other. But really, they're not the only supplements because you could say 2 and 7 are supplements. All of the pairs that we've identified that have congruency to each other also share supplements with everyone else. It's a very fun and exciting bunch of relationships, and you will probably see a good 5 or 6 questions on the ACT involving alternate interior or alternate exterior angles, or somehow seeing this kind of a figure drawn where there are parallel lines intersected by a common transversal. I promise you that. But just because there are 2 lines intersected by a transversal does not mean, this is a big warning. My book is telling me to do like this big caution sign right here. Caution your students, it looks like this. It says make sure your students know that only if these 2 lines are parallel will this relationship work out? I can draw any two lines I want to, and then put a transversal through them. The transversal is one that intersects both of them, but only if the first two lines are parallel can we count on these relationships being true. Otherwise, they're definitely not going to be true. You're not going to have all these different corresponding angle. I mean, you could have some of them be congruent, but you can't count on it. Particularly, I think if they're perpendicular, you can count on certain relationships, but we're not going to go there. Turning the page. Wait, when am I supposed to stop? Here we go. Yep. Turning the page. We're gonna do example 13. We're gonna work through it. So example 13 says identify the alternate interior, alternate exterior, and the corresponding angles. Look at that diagram and answer the following questions. So EF and CD and GH are straight lines. Also, EF and CD are parallel to each other, as marked by that little arrow dealy. So it says identify two pairs of alternate interior angles. Look at an enthusiastic math student. He says alternate interior angles are the pair of angles that lie inside the parallel lines and on opposite sides of the transversal. You might need to really look at page this example 13 a lot. If these ideas seem like I'm speaking Russian to you right now, sometimes it can just be helpful to just look and see, gosh, those two angles look like they're about the same measure. And that can kind of help you remember some of these rules. Maybe I'm not supposed to say that because it seems like it's cheating. I don't know. I don't think it's cheating. Generally, you're going to find that they're going to draw things to scale in your book. I guess you can't always 100% count on that, especially if you have a checkpoint that your teacher makes. You can't count on things being to scale because I might not use a protractor. But taking a look, you know that A and B, they're the interior angles and they are alternate to each other. Same thing, or not, yeah. Did I say A and B? No. Look at your picture. You see the colors they use? You can tell those are alternate interior angle pairs. Angle FAB and angle GBC are alternate pairs. Oh, they give it to you. EAB and ABD. There you go. What about the alternate exterior angles? Similarly, there's an enthusiastic math student who's excited to tell you about alternate exterior angles that are the pairs of angles that lie outside the parallel lines and on opposite sides of the transversal. So the alternates are always opposite sides of the transversal. They're the alternate angles. There's the interiors and the exteriors. Make sense? Hopefully that makes sense. It continues on the next page. So turn the page. And they say identify the two pairs of corresponding angles. So those corresponding angles, there's one interior and one exterior. They're on the same side of the transversal. I feel like it would be helpful if I use this as example. So remember, we have the transversal. The transversal is really the thing that guides our discussion here. So the corresponding angles are going to be on the same side of the transversal, but one's going to be exterior on the outside of the box, and one's going to be interior. Here, we'll use this circle pen. One's going to be exterior, one's going to be interior. Likewise, exterior, interior. Also, I'm running out of colors here. Exterior, interior. And finally, exterior, interior. Those are your corresponding angles. They correspond to one another because they're on the same side of our transversal, which I highlighted in this color. The transversal. The transversal, let it be your guide. Cool? I hope you guys have questions. We're going to do one guided practice, and then we're going to call it a night or a morning. I don't know when you're watching this video. It's definitely a late night for me as I'm recording this video. So, guided practice. Let's do Good night. Let's go ahead and do them all. 1, 2, and 3. I don't have the luxury of pausing. Like I said, this thing records continuously without my ability to pause. I suppose I could edit, but we'll see what happens. Pause the video, do 1, 2, and 3, guided practice on page 36, and then you're free. All right, so taking a look, my answer key says there are many answers, and so it's whatever. But number 1, line AD, line EH, line XY, and line WZ are straight lines. And line XY is parallel to line WZ. It's kind of throwing me off that they did the parallel lines diagonal. Identify all the pairs of angles formed by the intersection of line AD with line XY and line WZ. So they're saying, okay, we're just looking at AD and then the parallel lines. So right now we're ignoring the transversal of EH and just looking at the parallel lines XY and WZ and the transversal AD. So this is yeah, so they want you to do the pairs of angles that are formed. So the pairs of angles, so there's corresponding angles. Corresponding angles would be, let's see, you've got ABF and ACG. Those are corresponding angles because they're on the same side of the transversal AD, and they're one of them's exterior, one of them's interior. You see that? Same side of the transversal. I have to draw this, don't I? All right. There's just no better way to do this than to recreate it on my screen. Zip and zip. And it looks something like this. Righty-ho, zip. Oh, and then we've also got this other thing going on down here, which right now we're not concerned with. But there we go. All right, so the alternate, so here are the corresponding angles. I'm just going to kind of, I'll use the highlighter, why not? So there's this angle and this angle. They correspond. They're on the same side of our transversal. One of them's here, one of them's the exterior, one of them's the interior. We can also go on this side. This would be the exterior, and this would be the interior. So those two are corresponding to each other. Once again, I could be and should be switching colors. So those are corresponding. Also, these are corresponding, and these are corresponding. Those are all of the corresponding angles. They are on the same, each pair is on the same side, and one of them is interior, one of them is exterior. Corresponding angles. B asks for alternate interior angles. So these are different pairings. So alternate interior angles. I guess they give you one, don't they? So since we're just looking at alternate interior angles, we're only going to be looking at the interior angles. So we're going to only be looking inside the box. Only be looking inside the box for the interior angles. So each pair, oops. So the alternate interior angles, they give you XBC, which is this one, and BCG, which is this one. So they're interior and they're congruent to each other. All of these pairs are congruent. I don't know if they really mentioned that. They're all congruent. And when you're doing these kinds of questions, you want to read the question very, very carefully. Always look for which transversal they're referring to. You might even just like put your finger on it, or like, I don't know, I set my pencil point on the points that I'm looking at, generally speaking, so I don't get mixed up. What's the other pair of angles? Well, there are only 4 tiny little angles, and they gave you one in the book. So the other one should be simple enough. I don't think we've used this color yet. What is that, periwinkle? light purple. Sweet. All right, problem 2. It says name the other transversal. The other transversal, there's this point and this point E and point H. So this is line EH. Just so you know, guys, I didn't really draw the little symbol jobbies. They have these little symbol jobbies showing you which lines are parallel. Let me try that again. That's better. So those lines are the parallel lines, and I didn't draw all the little arrowheads on all the arrows. These are lines. They have arrows. You get it. We're really just looking at the following along with the book. So answer to number 2, it's line EH. It's the other transversal to those parallel lines. Number 3, identify one pair of each of the following angles formed by the intersection of EH, that's this one, with the intersection of XY, that's this one, and WZ, that's this one. So A asks for a corresponding angle. Your corresponding angle could be, your pair of corresponding angles could be this one, EFY right here, and then it corresponds to FGZ right here. And you could also do this one with this one. Those names are HGZ right here and GFY right here, and so on and so forth. Hopefully you got correct answers, because it doesn't give me every single possible answer. I could just keep going. I'll keep going. All right, this one corresponds to this one, and this one corresponds to this one. Those are the possible pairs you could have done. All right, option B. Find alternate interior angles. Well, if we're just looking at the interior angles, we know we're looking inside, in between the parallel lines. Those are the interior angles. So just look there. The ones that alternate, there's this one and this one. So that would be YFG with FGC. You could also have said that one and that one. Those alternate BFG, big friendly giant, and FGZ. Because I didn't label all the points, but you have to use the points to label the, give the answers. So your answers would be given like this. Angle BFG and angle FGZ. This is how you would mark this correctly in your homework. Just so you know. You have to mark it with angles like they're doing. Finally, letter C, alternate exterior angles. Since it's exterior, we're going to look here in the exterior, in the outside areas, on the outskirts of town, on the margins of society, on the wrong side of the tracks. Hey, kind of does look like railroad tracks. So the alternate exterior angle pairs, you could do EFB, that one, and then you could do HGZ is its mate, that one. You could do EFY with CGH. And those are the two pairs that are possible correct answers. Fun times, you guys. This one went long. It only went long if you needed to see every explanation, which if you did, that's fine. Don't feel bad. It's all about learning, right, guys? It's the journey, not the destination. So, hey, it's been real. We'll catch you next time. Love, peace, and chicken grease. Amen. See you later.